We're going to talk about fetch and some patterns for resilience, scalability, and predictability. Everyone gets to do a Who Am I page. Oh, thank you. I'm a software engineer at Olo. I am a career switcher. I'm an aspiring writer and reader. I like weird sports, like rowing, cycling, rock climbing, and I did fencing in high school. I'm also the luckiest guy in the world. And I like emojis, but I use the wrong ones. My favorite one is joy, which really just means I'm old. So,
why are you the luckiest guy?
Oh, my life is really good, and I love my wife and great family. Okay, thank you. Sorry. Oh, I should mention this is my first talk, so if I mess this up, keep me posted. So the goals of the talk. I'm going to hope that by the end of the talk, we can recognize when we want to use these patterns. We're going to talk about algebraic data types. So thank you, Jock, for kind of laying the groundwork there. Yeah. And those sound scarier than they are. We're also going to walk through some patterns for hopefully more enjoyable and reliable coding. Again, Jock already covered it, but algebraic data types come out of the functional programming community, and they're really just a way to describe your data. If you've ever used a discriminated union, that's an ADT. So again, what is this talk about? Oh, this is getting cut off. I'm sorry about that. In a nutshell, there are patterns for working with remote data reliably. And what do I mean by reliably? That's really annoying. First, fault tolerant. They're designed such that every time you use it on a team, like you don't need to re-implement it. And we know the universe of like possible outcomes in advance. Again, strict typing. What is remote data? It's a word I'm going to use a lot. And again, it's an example of an ADT, an algebraic data type, and it's exactly what you'd expected. It's designed for working with data that's remote. Here's my implementation of it. This is very influenced by the Elm community and an engineer named Chris Jenkins, which is where I first learned about it. But we have remote data, and it's got 4 different states. It's not started, loading, success, which has a data property on it, which takes the type T, and then fail, which takes a message. Has anyone used XState? Anyone heard of XState? Cool. So this is the default state machine for XState, and if you look at it, it's really similar to what I just described. You've got idle, which I called not started. You've got a loading state, a success state, and a failure. Finite state machines can be used with this pattern. I will not be doing that, but it's pretty great, and the only reason I'm not doing it is because I can't get my team to adopt it. So what are the ingredients for this solution? It's going to be resilient. We're going to handle errors gracefully. It's going to be scalable. Again, every time we use this, it should be really easy so that we don't have to clutter up our code bases with a lot of extra code. And it's going to be predictable. We're going to know exactly what we're working with. So again, this is functional programming. If you're object-oriented, I'm sorry, but this is React, so I don't think I'm going to worry too much about that. One question we might be asking right now is, what about fetch? What about Axios? Why are they not enough? And ultimately, it comes down to 2 things for me, consistency and testability. So it's really easy when you re-implement fetch all over the code base to do it one way in one component and a different way in another. We're trying to avoid that. And testability. Axios in particular is normally configured globally for a whole app. It uses a singleton, which makes testing more difficult. We're going to avoid that. Everything's going to be wrapped in pure functions, and it's going to work great. So I said that I wanted you to know when to adopt this pattern. So what are some signals in your code base that you should be looking out for when you should start thinking about adopting this? If you're optimistically rendering it, or rendering your code, if you're asking a remote data source for some information and it's coming back and you're just throwing it on the screen, you're going to get a runtime exception, and those are not fun. If you're conflating a not started with a loading or a success state, this is a really common pattern. In fact, this is what Chris talks about in his blog post. It's how he prefaces it, where you go to Twitter and it says you have no messages in your feed, and then after a second you get a bunch. And that's because they were conflating a response with a loading or not started state. And then lack of error handling, as I've been talking about, repeated error handling. So if you're handling errors differently or repeatedly across your code base, you might want to think about this. And we're off to the races. There's going to be a lot of code. I'm sorry for the people who are outside. I'm hoping that it zooms in close enough that we'll be able to see it, but otherwise I'll be talking over it. Also, at the end of this slide, this whole deck is hosted, so there's a link. You can go look at it. All the code is open source, and there's a demo that we'll talk about as well. So first, a bog standard, throw it over the wall and just hope that it works approach to a React component. We've got a use effect. It makes a fetch to API/posts. In the rest of the talk, that's going to be just /posts. Sorry. I take it out of JSON, and then I just set state. And once we do that, I just put it on the page. I say, let's do this. There's no validation, no error handling, no loading screen. There's not a lot to go for this. So let's talk about some improvements. And what I'm about to show is not yet what I'm, like, the purpose of the talk. This is kind of like a middle state. And it's the way I used to do it before I learned about ADTs. Here, again, I've got the use state, or use effect, excuse me. But this time I've got some error handling. And I need to set it to state. So now I've got to use reducer. And the reducer. So what's going on here? We've got a switch statement with a couple different cases and a default. The default, you'll see, is asked false. And everything else is false too, right? We're in our default. And the other ones, you've got loading. So loading's true, is asked is not true yet, because like we're still in the middle. That's probably a typo. That should be is true. Success, and then everything is getting merged into the success track. So then we need to figure out if we've got a message, that means we're in error. And if we don't, that means we've got data. And now we can render confidently. We just say which state we're in, or we ask, and then we throw up on the screen. We can know for sure which state we're in. So what are some areas for improvement here? First is that reducers are really easy to mess up, as I just demonstrated, because I have a typo. They also allow for impossible states if you mess that up. There's no type safety in this approach, which means that we still run the risk of runtime exceptions, or we have to check our data all the way down the tree. Error handling happened at for every call. So if you'll recall, I had that catch statement. And so now, how would we make this look better? Well, let's get some strict typing. Let's build in some error handling. What about automatic retrying? And automatic header management. So if you need to inject some tokens or other things that your backend requires. And no impossible states. So I'm not going to, the footnotes, I've got footnotes. I like footnotes. The ones mean I'm not going to actually go into the details. The two means that it's available in the demo, but I'm not going to talk about it. And then the third, for no impossible states, means that you need to do a little bit more with some pattern matching that I also didn't implement. And then forced to handle all cases. That's the pattern matching. No impossible states was X state, and another plug for that. X state. Okay, so let's refactor the app. This is the same app, but with a few improvements. Use effect is now much simpler. We can declare upfront what data type we're going to get back. In this case, it's a list of posts, and then I'm just making a call to Git. We'll talk about that in a second. So what is Git? Git is a wrapper. It's a simple API that you can use across your code base. It wraps a method called request. What's request? Request is a wrapper itself, And this time it has some extra niceties, and it wraps around Axios in this particular case. So what are those niceties? Automatic retries. So we can default to 0, which is line 3, but in our get, we passed in a 1. So if you fail your get and it's due to something that the replay timeout wants to handle, it will just retry that. You don't have to do anything. It also has error handling, or this parse error helper. Again, the actual implementations are in the demo, so I'm just going to skirt past that for a second. Okay. And then back to the actual implementation. What are we doing? We are fetching posts. This is basically a thunk. When it starts, we dispatch an action to say we are loading or pending. And then when we get a response, we know that we've got data, or at least a response. That fetch post is an action creator. It's very straightforward. It takes a response and just puts it in the payload. And you'll notice on line 5 that we've got the as const. That's one way, and it's my team's preferred way of enabling strict typing within the reducer. And so here's our reducer. It's a single reducer. It's a little small. I'm going to zoom in a second. But again, we only have that one action. So the reducer is very simple. It's got one action type that it needs to switch on. And what we really care about is the payload. And the reducer has a state, which is defined as post state. And posts are remote data that receive a list of posts. I wish I had been as creative as Jock and done something different than posts, but thank you for forgiving me. Within the switch statement, we can now say, are we pending? And if we are, we know exactly what we've got. We can return that. Is the response okay? Well, in that case, we know that it's a success, and we can just put the data in on that post object and go on our merry way. And in all other cases, the response has a status, and that's our message, and we're just going to put that and send that to the client. So how does all of this work? Well, let's talk about some of the types that go into all of this. The first one we've already talked about. It's our remote data. And it fully describes what we expect to be present on the object. Again, it's got the data and the message, and those are defined in the generic types. Fetch status is kind of where we are in the life cycle of the event. So it's that pending, it's the pending or the loading or the success. And then I've added some ergonomics, so some type guards if those are useful, because sometimes maybe you don't want to go through everything and you just want to know, is my message okay? Or are we loading? And then again, remote data is the shape of the data. Fetch status is where we are in the call. So circling back to the full app, what did we actually achieve with this approach? We've got error handling. It's resilient. We don't have to do anything. We just know that if we're in a failed state, we can display our error message. It's reusable because all you need to do is get. Like that little API is all you need to do to make a call, and it's even pretty easy to abstract that into a thunk itself and have a even slimmer API. And lastly, it's predictable. When we're in a state, we know exactly where we are, and we can just render it. We don't need to confirm all the way down. Now, to be clear, I trust my backend. I know exactly what my API is returning. If you don't, use IOTS, which is what Jack just talked about. So a quick live demo. Let's see how this goes. I don't have network. It's going really well so far. Hold on. There we go. Okay, so all the resources, again, are linked at the end of this, and I'll just kind of leave that up for a second. But this is an app. I've got a index, which I'm currently using my resilient in use rather than my standard. The standard is the first example I showed. And what happens is that when I call, what we're really paying attention to is this top part where we can just access with confidence. This is the whole state. And every time I call, sometimes I get a bad status, sometimes I get data. But if you look at the code in the example, there is no I don't have to do any conditionals, I don't have to do any checking. And that's kind of the real feature that I wanted to focus on. So with that, any questions? Yeah.
So what did you use to make the presentation? Because I really like the highlighted code.
Yeah. So I spent way too much time learning MDX Deck this weekend. I like writing in Markdown. Hello? Okay. MDX Deck is an open source tool to convert basically Markdown into a presentation. There are some styling glitches, but thank you for forgiving me on that. Yeah, Jack.
Is it hard? Oh, thank you. Was it hard to get buy-in for algebraic data types at your company?
So no, because I didn't have to sell them.
Okay.
One of my peers, we've got a small team, and my peer was like, hey, we need to model fetch requests for a new app. I've got a pretty cool idea. He likes Elm, so he shared some of the blog posts with us, and I was sold, and that's why I wanted to share it, because it's really cool.
Yeah, it is. Cool. Thank you.
Any other questions? Okay, thank you. Thanks for being a great audience. Some of the blog posts and the resources.